Hello, my name is Olga Klinsevich, and today we will talk about roof modeling in InstalSystem 5. But before traditionally we'll start with a short presentation of our company. I will show you some information about InstalSoft, about InstalSystem 5, and about all available kinds of technical support. So here is our website, instalsoft.com. Several language versions are available here. The information about our products, available models in InstalSystem 5 with the description, next you will find available market versions. You can download demo version, buy a full version, or check the available customized software version. Here you can discover the advantages of our software and find some information about design process in InstalSystem 5. Here are our offers for partners, for designers, for education, price list, and here is our technical support. It's help system, instructional videos, trainings and advices, publication info, software technical specifications, and list of standards and methods. Here are download files, info about our company, and contact list. So here is our help system. There are a lot of educational articles in several languages, and also sample products. You can download one and use it to study the topic interesting for you. And here is our YouTube channel. Different video materials are presented here, also in several languages. So as our today's topic is related to the building construction, these video materials can be useful for you. IFC beam building data interpretation, preparation of building structure, and beam designing. And please note that you can subscribe to our YouTube channel. Also, you can find us in social networks, Facebook and LinkedIn. So please subscribe in order us to be closer to you, to provide you with timely information about our news and important events. So we will start our main topic, modeling roofs in InstalSystem 5. The aim of our presentation is to acquaint you with advanced methods for modeling roofs of various constructions with 21 design cases. You will see how to model roofs in InstalSystem 5, what are the general rules, how the new generation program facilitates and supports the introduction of roofs, how the program supports us with diagnostics, how to define elevation and slopes, and many other unique and useful functions of InstalSystem 5 which can be used to model roofs. We will start with typical cases and then we will move on to more advanced examples. And in the description to this video you will find the list with tips for you, what you should remember when modeling roofs in InstalSystem 5. So here is our final file. We will create all these types of roofs today. And please note that based on this construction, program will automatically generate thermal partitions, logical partitions with all necessary dimensions and will assign them to the appropriate rooms. And before we start modeling roofs, I would like to switch for a few moments to another file and to explain you some important aspects. You need to know that program provides several ways to create building partitions and roofs in particular. The choice will depend on the source file, which is used like an underlay. If we use DWG, DXF or PDF file, we have two scenarios to create partitions. We can create partitions manually with the use of appropriate tools provided by the program. In our case, it will be roof. We just need to choose necessary function, roof, and draw it in accordance with the project file. And also we need to draw roof edges. Here it is, and another one, and then correct elevations with the use of Control key when we can choose several of them. And now we can observe the result of our manipulations. The second scenario is that we can modify the roof created automatically after executing the function automatic walls, slabs and roofs. Just improve the shape of the roof, add roof edges, and enter necessary values of elevation. So that's how it works. Also, InstalSystem 5 provides the opportunity to use IFC model for the creation of building construction. In this case, all elements of building construction, including roofs, will be interpreted from the IFC file. All these aspects and many others we will explore more precisely right now. And here is the file which we will use for today. As you can see, it already contains slabs and walls. We will create roofs manually here for each type of 21 examples. And for each room, we will set necessary data also manually. And here is the file with manually drawn rooms and building contours. So here we will use this function, automatic walls, slabs and roofs, to generate partitions. So as you can see, program automatically generated walls, slabs and roofs. In this case, we need to run calculations of the building. Now we will check errors. As you can see, this icon is green. That means that we have no errors and warnings on this stage. And now we can modify these roofs according to necessary data. And please note that these flat roofs were created taking into account the value of elevation of rooftop, which is defined in the stories management. And based on these simple building constructions, program has already created thermal models with logical partitions. And one more important point in the aspect of using the function of building generator. In practice, we can often meet with the situation when there are two or more roofs for the same building. For example, like we can see in this drawing, this building consists of two parts, two-storied part and three-storied part. And we need to create two roofs on different levels with different slopes for this building. So, what we need to remember: program creates only one roof for the last story. Here it is. For this part, slab was created. We can see it on 2D view. Here is the slab. And in this situation, we just need to choose the function of surface division and to divide this slab into two parts. One part and another. And for this part, we will use the function of converting slab to roof. Just so easy. And now we have two separate roofs and we can define all necessary data for these roofs. Of course, we can delete unnecessary partitions and just draw manually what we need, but this function makes the process very quick and easy. Before we start working with our main file for today, I will show you some more things that we need to know when modeling a roof in InstalSystem 5. In order to draw a roof with a certain slope, we need to know the angle of the slope and the length of the roof edge at a known rooftop mark. Based on these values, all other marks will be calculated. Or otherwise, if we know the marks, the program will automatically calculate the slope. So let's turn to this example. Here is 2D and the length of the edge is 10 meters. Here is our roof. So if we put here the value of the slope angle, you will see that the program automatically calculates these marks. And on 3D view, here is our roof. The elevation of the roof top is 10 meters. The angle of the slope is 30 degrees and this mark 4.23 was calculated by the program automatically. So let's see how it looks here. And what is very important to know that after we run calculations, the program will automatically cut the walls according to the data that we put for the roof. That's how it looks on 3D. Such a roof and walls, we do not need to cut them manually. So here it is. Here is our main working file for today. As you remember, it contains already created walls and slabs. 21 examples of roofs are presented here. So to start modeling roof, we need to get acquainted with this group of commands related to the roof. It is roof itself, add roof edge, dormer, join roofs, and opening in roof. So let's choose this function and just insert roof in our first example. It will be shed roof or single pitch roof. So, we know these marks. We need to put it here. And now we need to put these marks or just to enter the angle of the slope. like this. So let's turn to 3D view and observe it here in the construction mode. And if we turn on thermal mode, we see nothing, because to create some thermal model we need firstly run calculation of building structure. So let's do it. As you can see, program automatically cut walls, and here in this scope we already see created thermal model of this building. Our second example is Gable Roof or double pitch roof. So we need to insert roof here, and to change these marks, now we will add roof edge and just enter the angle of the slope. So as you can see, these marks are calculated by the program. Let's run calculation of building structure. And as you can see, thermal model has been created for this example also. So our next example will be flat roof. We will model this roof in a simplified way. We just need to enter necessary marks, but we should remember that flat roof is never absolutely flat, because there is always a basic slope of 3 degrees, and we can meet larger surfaces with the slope of a flat roof. We also can have roof outlets, and it's very important when designing rainwater drainage system. And in the aspect of flat roofs, I would like to show you 5 examples. So here is our file, and I would like to take the opportunity and to show you how we can deal with situations that often occur in practice when plan views and roof views are located on different underlays. So we need to open underlay scope, and here we choose import underlay. Here we choose necessary underlay and open it. Here we can choose the method of loading PDF underlays, and this is it. Now we need to scale it. To do this, we need to measure the length of already existing element, for example this wall, and now we choose the same element on the underlay with roofs. Choose this function, scaling, and here we need to enter the value. So now we have scaled underlay, and we need to move it to appropriate position, just on this way. So now we have 2 underlays, one on the other, and we can easily draw roofs with edges. And for this case, here in General Data in Storage Management, we have this value for elevation of roof top. And when modeling flat roofs, we need to remember that there are two variants. The roof can be boarded by inner contour of the walls, like this, on 3D view, or the roof can be boarded by the outer contour of the walls, like this, and on 3D view. And now we just need to add roof edges. This one and this one, and here we will set this value. That's how it looks on 3D view. For this flat roof, we can set the edge of the slope. And now we will create some kind of a butterfly roof. Add a roof edge. Enter the values, for example like this. Here is on 3D. And let's make a computation of building structure. As you can see, the icon is yellow, that means that we have some warnings. Let's check diagnostics window. Shape of the roof element is probably inaccurately drawn, and this could be the reason for the lack of recognizing of the room. Here we have two components, indicated place of the problem. As you can see, arrow point the problematic place, and the element with inaccurately drawn shape. It's our roof. As you can see, the problematic place is highlighted with red. Here we need just to improve the shape of the roof. Let's do it, and let's calculate building structure once again. So here is it. The icon is green, that means that we don't have any problems with the calculations. And if we hide all walls on 3D, we will see that automatic rooms were created for our cases. So let's go to our next case. It's complex shape roof, and you need to know that program provides two variants to draw such types of roofs. First variant, we draw it in accordance with the contour of the walls, like this, or we can make it in such way, and next improve the shape of the roof using openings in the roof in such way. Of course, which way to choose depends on each particular project, and it's up to you to decide which way you will choose. Let's calculate the project, and on 3D we will see that automatic room is created for this case also. And we have the last case left. Sometimes we have situations when we need to create a roof consists of several parts. So we can draw roof, one part of the roof, indicate its marks, and slope, and also let's observe it on 3D view. That's how it looks. And draw another part. Also indicate marks and angle of the slope by this way. Here is slope value, and let's observe it on 3D view. So we have roof consists of two parts, of two roofs. Here we can run calculations. Diagnostics window is empty, and please pay attention that we have wonderful function. Here is it. Join roofs. If we need to join roofs, we just can use this function, and in this case you can see that we have one roof just with the edge. And our next case here will be hip roof. It's a 4-pitched roof. We will draw it like this. Let's correct marks and add edges. One more we will add here, and one more here. Let's set the angle of the slope. Here is it on 3D. We will calculate, and we can see that the roof is modeling. We can hide all walls on 3D, and as you can see, automatic room is created for this case. Our next case is hip and valley roof. It's a 4-pitched roof with a simulated dormer. Please note that today we won't explore the dormer like an element of the roof, because we will have a separate tutorial on this topic. Today we will just study the opportunity that program provides us in modeling such type of roofs. So we will start exactly like in previous example. We will draw the roof itself. Then we will put necessary marks. And add roof edges. Here. Here. And here. Now we will specify the angle of the slope here. Add edges here and here. And specify the angle here. And as you can see, some edges became red. That's how program gives us a signal that these elements can be realized. What we need to do in such situation, we need just to improve the values on our drawing. So for this value 561, we will correct it in accordance with this value 503. Also, we will correct these two values 3.66, and now you can see that everything is okay with our drawing, and let's observe it on 3D. So here is the construction scope. As you can see, the roof is created. Let's make calculations, and also automatic room is created for this case. And as we can see, thermal models are presented also for all these cases. Our next case will be Jerkinhead Roof. Here we just need to draw the roof element itself and specify necessary values, necessary marks, and add roof edges in right places. This, and also here, and one more will be here. And now we just need to specify marks according to the project, or to specify the angle of the slope. So as we can see, program has calculated all these values. Let's observe it on 3D. Here is our roof. Let's calculate. As you can see, automatic room is created, and also thermal model is created. The next example is M-shaped roof. We just need to draw the roof and add necessary edges here. We will set this mark 304, also this. Here we will have 580, and here also, and we will set 45 degrees for this angle and for this. We calculate the product, and let's observe on 3D how it looks. As you can see, we have automatic room and also thermal model. The next type is Mansard Roof or Polish Mansard Roof. We have already created something similar, but pay attention that here we have one more additional edge. We will draw it. Here is it. And also here we need to know that we should draw it in parts. We can draw the whole edge in this case, and here we will add this one. And we will put necessary marks. Here it will be 6.27. Here it will be 5.87, and also we will set this value, the value of the angle of the slope, 60 degrees here and here. So let's calculate and let's see it on 3D view. This is thermal model. And also this construction scope, we can present all walls on 3D and observe our building in this scope. The next type is Saltbox Roof, a symmetrical roof. Here we just need to put the roof, the edge of the roof, and set the value of the slope angle. Here it is. Let's calculate. And on 3D we have such type of roof. And also thermal model has been created. The next type of the roof will be Sawtooth Roof. So we put roof here and add necessary edges. Here. Here. One more. Here and one more here. Now we need to set necessary values. 5.22 will be here, 360 will be here, 5.22, 316, and 5.22 is the last, and the last one, 316. So let's calculate. Here it is. Let's present our walls on 3D, and here is our building with the Sawtooth Roof. Thermal model has already been created. The next roof type will be dropped eaves roof. We put the roof at the roof edge, set the angle of the slope, and now we just need to draw opening in the roof. Here is it. Let's calculate. And on 3D, here is our building, its thermal model. And here is our building in construction scope. The next is butterfly roof. We draw the roof itself at edge of the roof, set necessary marks, and here we need to know that if we would like to draw such type of a roof, we can't set the value of the slope of the roof. We need to enter the value of this mark manually. And you will see that program will automatically calculate this angle. So let's run calculations. And on 3D view, we will see such roof and its thermal model. The next type will be curved roof. If we would like to draw it very exactly, we just need to draw more edges. Here we will put only 2 and set necessary marks. 3.0 for the edge and 2 here. Let's calculate and see how it looks on 3D view. So here it is. Of course, if, how I have already said, if we need a more exact roof, we will draw it with the use of more edges. It depends on the type of the project and on your wishes. The next type will be Clerestory Roof. Here we need to draw 2 separate roofs to enter necessary values. Here it will be 3.71 and the next roof, here it is, here also 3.71 and here it will be 4.82. This is it. So one roof and another. On 3D view it looks like this. Let's calculate. So this is our building. This is thermal model, and please pay attention that program recognizes this type of wall like external wall and this type of wall, here is it, like internal wall. And our next type will be A-frame roof. We just need to enter the roof, to add the roof edge, enter necessary marks. Here we will put 60 degrees for the angle of the roof and run calculations. On 3D view we will have such building. And what interesting you need to know, if for example we have additional slab like this in such type of the buildings on the different elevation, for example like this, if we run calculations for such case, we will meet with the situation when there is warning. The slab should be trimmed by roof. So in our program we have such function trim slab by roof element, and if we will use it, we will see that this slab was trimmed by the roof. The next type will be combination roof. This is the roof with different angles of the slope. So we will add edges on it, and please remember that in this case we can draw the edge by the circle. We will just make it in different parts in this way. So we need to draw another edges here, here, and the last one. We will put necessary marks. Here it will be 6.84. Here it will be 4.16, and here it will be 3.83. So let's make calculations. Here it is on 3D view. And the next case is Dutch gable roof. It consists of 3 parts. This is the first. Second. And the last one, the biggest part. Here is it. 1, 2, 3. And now we will add edges. Here. Here. And here. And now we will enter necessary values. Here and also in these places, and these values, and also this. Here it is. And for this part, and the same for this part. And now we can run calculations. And open 3D view. So here it is. Dutch gable roof. The next one is pyramid hip roof. It is rather simple. We just draw the roof and add edges here, this one and this one. And now we will put necessary marks here and also here. And let's calculate. And on 3D we have such roof. Next example is a Gambrel Roof or Mansard Roof. We draw the roof, we draw edges. Please remember that you can use the F3 function to insert last used elements. And now we will set necessary marks for this edge, for these two, and here let's enter the angle of the slope. So we run calculations. And on 3D, here is our construction scope, and here are thermal models. The next is Hexagonal Roof. This is a 6-sided roof. So we draw it, edges, the next one, and the next one. Here is it, and our next step will be necessary marks. So let's calculate and observe it on 3D. Here is thermal model, and here is the construction of such roof. And the last type here will be monitor roof. Let's draw it. The roof itself and the edge. Here we can set necessary data. It will be this value, and now we need to use opening in roof function. Just in this way, and draw another roof with the edge and also put this mark here and the angle of the slope. So here it is on 3D view. Let's make calculations, and we see such type of the roof created in our program. And here is it thermal model. So as you can see, it's rather quick and easy to model different types of roofs in our program. You can practically realize any type of them. And now we will go through a more advanced example. It's a cross-hipped roof. Here we will discover additional tips and possibilities that program provides to the designers in modeling roofs and also in generating thermal partitions. So here we have two-story building. Let's observe it on 3D. So let's create the roof for this building. We just need to draw the roof itself and add necessary edges. And the edges this one, the next, this, and one more will be here. And the next we will set necessary values. Here will be 663, here will be 566, and here will be 342. And as you can see, we have the angle of the slope 30 degrees. And now we can calculate. The icon is green, and let's observe it on 3D view. So that's how the roof looks like. Here it is. And if we hide all walls in 3D, we will see automatically created room. And also let's hide the roof. As you can see, the room is created for the first story and also for the second. And also we have created thermal model for this building. And please pay attention to one more important aspect. We have already discussed it, but I would like to show you it here on more advanced case. For example, if we change these marks and lower them on 1 meter. And here also we will change to 242. And on 3D view, we can see the roof that we created now, and here is the place of the roof created previously. So let's calculate, and now we will see that the icon is yellow. Here we have warning: the slab should be trimmed by roof. Verify and use the trim slab by roof element function. So this is the function. We can trim, and now we see that there is no elements to be trimmed. And let's calculate once again. We see that the icon is green, that means that we don't have any warnings. And here in hidden energy scope we can see thermal model created for this variant of our building, and also logical partitions and also rooms with necessary shapes and calculated dimensions and areas. And finally, this is our last example. This is IFC model downloaded from Revit or ArchiCAD or some similar program here to install System 5, and we will use it like an underlay. So to create partitions from such model, we just need to use this group of commands of interpretation elements from the IFC file, which can create rooms, walls, slabs, roofs, windows, doors, and etc. So let's turn to our construction scope. You see that walls and slabs have already been created, and now we will create roofs. So it can be done very easy. We choose necessary element, in our case this is roof, and choose this function, creates roof from an IFC file. Here it is, and we see such roof in our construction scope. And now we will create a roof for this part of our building. Please pay attention that this roof consists of 3 parts, and program gives us the opportunity to join these parts in the case of necessity by 2 ways. First way is this one. We choose these 3 parts using Ctrl key, and now we will use this function, creates roofs from an IFC file, and program provides us to join these items into one. And this is a hint, elements can also be joined at a later stage of the design by using the join roof function. Let's also explore this function. So we choose no, and here in construction scope we see that these parts were created, these roofs were created. We can run calculations, computations of building structure, and now we can choose these parts with the use of Ctrl key and use this function, join roofs, if we would like to create to join these parts of the roof into one. So this is how the program creates a roof with the correct edges, with the correct angles of the slopes, and basically we don't need to do anything else in this case. So our next stage will be roof windows. This function is available here, and what we need to remember when we use these elements in our product. First, we need to put a window on the roof which is preferably already ready and calculated and contains no errors. Second, after inserting the window, we do not have to do anything because the program will automatically update our model and also thermal model after inserting the window and performing calculations of the building structure. And the program will assign the window to a given room. And this said, remember that we can't put windows on the edges of the roof. If we have such situation in our product, we need to divide such a window into 2 elements and move them close to each other. So let's choose roof window and just put it somewhere here. If we need to improve its sizes, we can do this here or here in data table. Let's set the font 3D. Here is it, here is the window, and if we make computation of building structure, here in heat and energy scope, we will find this partition. And also I would like to mention about some other product elements. Construction elements like doors, windows or openings in the wall. They also should be created after this stage, after the roof modeling, because we often have a situation when these elements protrude above the roof surface. This is wrong situation, and of course we should avoid this. The program will not inform us about such situation, but we can see it easily on the 3D model when the roof is created. Another aspect relates to the designing of sewage installations in InstalSystem 5. The program itself will correctly determine, based on the roof edge, where the exhaust pipe ends. When we do not have a roof, and this may happen because the sewage model doesn't require the creation of building structure, the exhaust pipe will simply take into account the elevation of the rooftop from the storage management. But when the roof is created, such an exhaust pipe will position itself accordingly. So this may be the reason to model roof even when you only design sewage installation in our program. So I think that's all about roof modeling. You can see what a quick and easy process is roof designing with the use of tools provided by InstalSystem 5, and how it's simple to make interpretation of roofs from the IFC file. So thank you for your attention, thank you that you are with us, and goodbye.